the 0th element has been inserted into the binary search tree. So I will start from I equals to 1. And here the insert function will be called insert, and as the array is globally declared, so which element to be inserted, that we don't have to pass, but only we can pass the index of that particular element. So I am passing the value of I, and after that I am where first the insertion will take place compared as a child of which parent of initially it will be considered as a child of root node. So I am also here passing the index of the root node, which is 0. Now this is the parameter. With this parameter, the function insert will be called. So now I will write the function for this insert. Write the function. The first I will declare the function here void insert, and I'm passing the parameter int I, that means the index of the array element which will be inserted next currently into the binary search tree, and another will be index, which will give you the index of the element with which it will be compared, that whether it is left child or right child of that particular element, which have the value, which have the index value, which is stored in this index variable. Okay, so that is the declaration. Now I will write this function to define the body of the function. Okay, so what I have to do now, because I have to check whether now, and so I have to check whether the new element, or which is at index 1, and so how it can be accessed? It will be AI. So it will be AI. If it is less than the array element, which is less than the array element, and the index of that element is stored in the variable index, will be compared. If it is less than index array index, array index, because this element of that array which is to be sorted will be compared with the nodes of the binary search tree. So AI is compared with array index. If it is less than of array index, then the next shift will be there, and another case will be there if array AI is not not less than array index, and it can be greater or equal than array index. So that goes to else section. So this is else. So that will be written later. First I will write if it is less, and the AI value has less than the current root node. So then it will check whether the current root node has any left child or not. So it will check. How to check it? If the current node in the binary search tree with which the AI array element to be compared is array index. So if left child, it means array index dot left. Okay, array index dot left. If it contains the null value, that means equals to null, that means there is no left child of this element, and the array element should be now the left child of the new element in the binary search tree, because it has no left child, but the value of array element is less than has less value than this current node of this binary search tree. So how to insert it? Now this array index, this new array element would be the left child of this current node of the binary search tree. So what will be the array index dot left value, which will point to the left child, which is the index of the left child, which is I. And now the array of this array of left is this, then array I of this data will be equals to A and R. Now this new node, which is which has the index I, this new node, so its left children is null, and its data will be equal to the array I. Its data will be equal to the array I. So that it tells you that the ith index of the ith index is this. It is the left child of this array index, and it has left child, no left child, so null. And what is the value of this nodes in the binary search tree? That is, the array I will be equals to the AI. And again, its right children will be null. The right child will be null. So it is equals to null. So it is inserted, then it is inserted, and but if array index is not equals to null, that means AI is less than array index. Current node in the binary search tree, this array element is less than of that current node of the binary search tree, but it has the left subtree also. Now it will go to the it will check whether the left root node of the left subtree, whether it has any child or not, and it will be compared with that left node of this root subtree. So again we have to call the insert function, and here the parent node with which the array element to be compared, that is the now we have to compare with the left root node of the left subtree of the parent. The parent node is the root node of the left subtree. That will be the current parent with which the array element which is to be inserted into the tree, that will be compared. So we will, if is not the array index left is not equals to none, then again we will call the function insert, and here I will pass the index of the left child. So index of the left child of the current node, which is array index dot left. So this will be